Welcome to Performance Upgrades. I'm your host, Dave Moss. The show is brought to you by SportBikeWrench.com. Performance parts and professional advice. Remember, when you buy from Sport Bike Wrench, you support our programming here at On The Throttle.
We're here at AFM, Jerry Piazza, GP Frame and Wheel with our unfortunate R6. And Jerry's going to take a look at it. So, first of all, for us, describe your machine and what it does.
Well, this is considered an articulated arm computer measuring machine. The ruby tip, in 3D space, the computer always knows where it is, and it allows me to define geometry in 3D space, and I could plot that on the computer. Okay. So that's what we're going to be doing. I'm going to be measuring the ends of each axis of the motorcycle so I could see that on the computer, and then we just ask for the math, and we'll be able to diagnose if there's a problem and or help with setup.
Now, over the years, how many bikes have you measured?
You know, it's hundreds at this point. You know, I've had the arm for what, almost 5 years now, 5-6 years, and it's always busy. I'm always measuring. I'm always here. So I don't even know. I guess we can count them on the computer. I've got so many files. I don't even know what to do with them all.
Now, in prep for measuring the bike, there are certain things we have to do. So why don't you talk us through the preparation about getting the motorcycle ready to measure?
All right. Well, one of the biggest things is most people have to understand that after crashing, a bike will torsion and move, and because of friction, it doesn't always come all the way back. So I like to term it as a shakedown. I like to ask everybody to loosen things, all the components of the front end, the rear axle, so that we can release all the friction, so that when I measure it, it's a true indication of what the components are doing. Very important to do that. I always put a jack under the bike. I like to measure the bike extended. It seems to be the most repetitive data because weight, spring, sag, setups, that is a bigger variable. So I like to have the suspension extended. For as long as the gravel's out of the tires, you know, and a little less dirt would be nice. But for the most part, that's it. Just basically clean up the bike, give it a shakedown, release its friction, and let's measure it up.
And then are there set measurement points you use that people will see when we actually film you measuring the bike?
Well, yes. Like I said, I touch off the ends of each axis of the motorcycle. So the steering stem, top and bottom, the top and bottom of each fork leg, the ends of each axle, including the swing arm pivot point. And those are the critical geometry points, as well as the wheels that help us define the bike. Yeah.
All right. Well, we'll let you get busy.
All right, let's do it. To define a point in 3D space, you have to define two features. One, you have to define a plane, and then you have to define the center of the feature and put that point on that plane. That'll give us a point representing the end of that axis. So, and it takes a minimum of 3 touches to define a plane or the center of a circle. We've defined the plane of the top stem. That basically completes the point for the top of the stem. And we continue. The nut's not an accurate feature to touch off on, so I remove it because the machined axle is actually a better point. That's called a guided point measurement. And a guided point measurement is, since I don't know where the center of the wheel is, but the computer does, I'm allowed to drag the probe across the wheel, and when it finds the center plane, it'll take the point. Very cool stuff. The reasons we do the wheel, since the bike is in the air, and we need to establish a proper ground plane so we can look at the geometry, I'll need to physically determine a ground plane, which is why I measure the wheels, and we'll do that on the computer. I'll show you that later.
All right, we're ready to go. We've got our sheet back. We've got our readout. Jerry will give us all the numbers, so let's start from the top.
Okay, well, basic geometry first. Look at its posture. The wheel radiuses, of course, I put at the top. Most people are not so concerned about the actual ultimate diameter of the wheels, but I have the data on the sheet anyway. Our rake angle, bike is sitting at 24.4 degrees of rake. Our trail is at 102.9 millimeters of trail.
Okay, on the front end then, standard figures you'd see on rake and trail, 24 to 26 and 96 to 105?
Yes, I would say more like 23.5 to 24.5. I don't see too many rakes up over 24.5, not on the current sport bikes. Some of the older models will have that higher rake, but nothing current. And the trails, yeah, I find that most of the racers now are optimum trails are anywhere between from 95 to 105. It's a broad range, but it depends on the bike, size of the bike, and the setup. So I've seen numbers as high as 108 on some of the R1s. I won't divulge who. And then he asked me not to. But okay. But the average is about 102, 101, just over 100 millimeters, yeah.
Okay. So on to our next key and most important one.
The swing arm angle, the infamous swing arm angle. This one is postured at 13.2 degrees. That is the angle from the ground and the swing arm itself. And this one's sitting at 13.2 degrees of angle. We monitor the fork height above the clamp so that we can just track that where the guys are setting that. We know what the offset of the triple clamp is.
Right.
That's at 30 degrees. And then I provide other data like wheelbase, overall fork length, and that's pretty much covers the geometry of the bike. And then to continue, we look at the alignment. I like to look at the roll, pitch, and yaw of the motorcycle, which is like an airplane in a way. That's what we refer to the geometry of the bike's attitude of the axis. So the steering head should have 90 degrees to the swing arm pivot point. That's a standard. Now, if it is not, then I could measure that. And this one is measuring at 89.85 degrees. That's telling me that sitting on the bike, the steering head has a slight counterclockwise roll error. Now, like a plane, inline is a roll factor. The rear axle adjusters, when you're looking down at the rear wheel, that would be a yaw attitude. Okay. And then, of course, pitch would be like what your rake is. If you were to collide into a wall and you lost rake, you would lose pitch. That's what's happening. So that's what we're seeing. So we're looking at a roll factor of 89.85, which is within spec, and that's acceptable. Okay. Fork twist doesn't look so happy. It is what should be 0.0 is up to 0.4, which is telling me it's almost a half a degree of twist, which means the forks are not really parallel.
So what Jerry's talking about here in the forks is when a bike crashes, the tubes will rotate. And they might rotate in the direction of the crash, and the crash side will rotate more. So then you create a turn point which turns the triples around. And when you crash, sometimes you'll look down the forks and see the forks offset because the triple's bent, and it can be bent this way or it can be bent that way. So instead of the forks going up and down like this, they're trying to go like that. And that's what happens with forks and why you have to undo these, loosen everything up, and make sure these slide properly.
On Yamahas, they are kind of soft, and it could be a combination of the triple clamps or the forks slightly bent, causing this misalignment. Or it could also be friction. So another reason why you want to shake it down and make sure that's not the reason I'm measuring a misalignment.
In other shows, particularly one in Vegas, we went ahead and loosened lower triples up and loosened everything else up, and the bike seemed to come back into alignment. Yeah. And we tell people, if you low side the bike, at least undo the lower triple and loosen things up.
Absolutely, you have to do that. Anytime you crash a bike, the best thing you could do is loosen the whole bike. Most people don't want to go through loosening a whole motor. But I do recommend always loosening at least the front two motor mounts, as well as everything about the front end, and also re-loosen and retighten the rear axle. That's a great thing to do after anytime your bike gets a jar. Right. For sure.
So we have a twist in the front end, so we need to figure out that's a fork and or a triple combined.
Combined, exactly. And you really can't analyze it with this kind of an instrument while the bike is assembled. Those kind of components, they need to come off, and you need to measure them individually. Okay. And that's the way that works. Now going on to the rear axle, Of course, the rear axle in an ideal world is parallel to the swing arm pivot. This one is showing 0.26 roll, counterclockwise roll, which means if you were looking at the end of the bike, the rear wheel is not vertical, it's slightly counterclockwise. To put a number on it, I'm measuring 1.3 millimeters higher on the right side of the swing arm than on the left side. That's showing how far the rear wheel is tipped, and that is a roll error. No. The axle adjustment is 0.0, which is good. You are less than a half a millimeter off on your axle adjustment, and that's good. Hey, we got that.
We got something right.
Yeah, but no, you know, the bike needs a little bit of love. But all in all, you know how we've seen worse. Yeah. So there it is.
All right, so we really should fix the front end. We should figure out why the rear wheel is tipped off its plane, and find out why that's happening. But other than that, those are the two major structural components we need to pay immediate attention to.
Correct. Actually, yeah, if I were to do anything first, the front end would be the first thing I would look at, being that it's the Yamaha R6 series. The rear axle has clearance in the swing arm, and if it also hasn't been shaken down, one side could be higher than the other, just the way it's sitting in the bike. So you got to look at those components. But all things being equal, a little bit of swing arm straightening and a front end routine, the bike could be in good shape.
Okay. Well, thanks for your time today. We know you're a busy man.
Unfortunately.
But fortunately for us, we know what we're dealing with. And that way, you know, when guys want suspension help or whatever, we're not chasing a ghost, knowing the bike's straight.
Exactly. You know, if your bike is aligned, then you can do your job. If it's not aligned, you know how you must be chasing your tail, and you spent all day and you still can't get it right. So, yeah, and I'm happy to be able to help the guys stay on the track and save their components, because we know replacing this stuff is just catastrophic. We can't afford to replace the components, so correcting them is the way to go.
Right.
Excellent.
Well, thanks for your time. Much appreciated.